Don't forget to subscribe, comment and like. Welcome. Revision Chemistry Form 2. Define the following terms. An isotope. What is an isotope? Isotopes, it is plural, so isotopes are atoms of the same element with the same atomic number, but different, but they have different mass number. So isotopes, they have the same atomic number, but they have the different number of neutrons. So when they have a different number of neutrons, it means that they are going to have different mass number, and therefore they are called isotopes. Atomic number. What is an atomic number? Atomic number is simply the number of protons in the nucleus of an atom. The number of protons in the nucleus of an atom is what we call the atomic number. So an element which has 5 protons is atomic number 5. Mass number. What is mass number? In fact, these terms are very important for you to understand chemistry. They are very, very critical. Mass number is the sum of protons and neutrons. The sum means addition. So mass number equal to, it means that mass number is equal to protons plus neutrons. So mass number is the sum is the addition. Therefore, when you ask it to define mass number, you simply say is the sum of the protons and the neutrons, or you can even add in the nucleus of an element. That's that. The table below shows atomic numbers and boiling points of element U, V, W, X, Y, and XY. The elements are not the letters are not the actual symbols of the elements. Study and answer the question. U, V, W, X, Y. Complete the electron arrangement or configuration in the table. So when you are writing electron configuration, always know that electron configuration, the first one must, the meaning that we have, of course, like hydrogen, we have electron configuration is for 1. But those that has electrons more than 1, the first energy level, the maximum electrons that can be contained there are 2. So that's why when we are writing electron configuration, we start with 2 for those atoms that has more than 1 electron. So now, for example, here this U has atomic number 3. Remember, number of protons equal to atomic number equal to atomic number is equal to number of electrons. Number of electrons, atomic number and the protons are the same number. So if this atom, this element U has atomic number 3, it means that it has 3 electrons. Therefore, electron configuration is 2, 1. You should always know that when you add 1 plus 2, it should give you the atomic number. V is atomic number 13, so we start with 2. we remain with 11. We go to 8 because the second energy level, the maximum is 8. So that is now 2, 8, that is 10, remaining with 3. And that is the electron configuration. 20, we start with 2. The next energy level, the maximum is 8. Because this is 10 and this is 20, the next one will contain 8. This is 18, remaining with 2, therefore 2. 19 will be 2, to 8, to 8, to 1. That is what we call electron arrangement. So we have completed the table above. Select the elements which belong to the same group. Elements that belong to the same group, they have the same number of electrons in the outermost energy level. So you just check here. Which two elements, or 3 or 4, that has the same number of electrons in the outermost energy level is the one that is outside there. This is the outermost and this is the innermost. So 2, 3, 2, so it means that U and the Y, they belong to the same group 1. They have this 1 electron. So select, so it means Y and U belong to group 1. Period, we count the number. Tunahesabu is energy levels 1, 2, 3, 4. We count 1, 2, 3, 4. 1, 2, 3, 1, 2. So this one has 2 periods. This is period 2, period 3, period 4, period 3, period 4. 1, 2, 3, 4. Period 4. 1, 2, 3, period 3. 1, 2, 3, 4. Period 4. 1, 2, 3, period 3. So the same period here we have 1. There are so many. These and these, there's the same period. These and these are on the same period. So you can write W and Y, or X and V. They are the same period. Give the name of elements V and, this one is V and Y. So V and Y, they are in group 1. So group 1 elements, group 1, therefore they are called alkali metals. Group 1 elements are called alkali metals. Give the element which does not react. We go to the table and check. Element X does not react. Why? It does not lose electrons, neither does it gain. It doesn't gain, it doesn't lose. This is stable, therefore no reaction. X, because it is stable. X does not react because it is stable. Write the formula of the solvent of element V. We go back and check V equal to aluminium. So we want to write the solvent of aluminium. Aluminium sulfate is written as aluminium sulfate. Aluminium has a valence of 3. Sulfate has a valence of 2. So it is this way, or using V 2 S over 4 and then 3. This way or this way is accepted. The grid ratio part of a periodic table, write the symbols of the first 20 elements starting with hydrogen to calcium in the respective. So you should master this. You should know that this one is hydrogen, followed by helium, lithium, beryllium, boron, carbon. Carbon is atomic number 6, and then nitrogen, oxygen, fluorine, and then neon. From neon we go to sodium, we go to magnesium, we go to aluminium, silicon, phosphorus, sulfur, chlorine, and then argon. There we go to potassium and then calcium. That is how you must master these elements like that. For the first 20 elements, you must have them in your head. State the name given to element Z in the above periodic table. Element Z, these elements which are not shown in the table, they are called the transition. They are called transition elements. An element P has two isotopes with relative abundance 65 and 35. If the mass number of two isotopes is X and 31 respectively, find the mass number represented by X, given that the relative atomic mass of element P is that. So that is the calculating of relative atomic mass, relative atomic RAM. How do we calculate RAM? RAM equal to mass of isotope 1 times the relative abundance over 100. We are going to use the overall 100 plus mass of isotope 2 times relative abundance 2, all of it divided by 100. So that's how we calculate mass of isotope 1 times its relative abundance plus mass of isotope 2 times its relative abundance divided by 100. So that's how we calculated the RAM. Now for this one, the relative abundance is 1. We have two of them. One is X, the mass number, the relative atomic, the mass is X. Another one is 31. But we have the RAM, which is 30. So we say that 30 RAM equal to mass of the first one, which is X, times its relative. The first one, the relative is 65, plus the second one is 31 times its relative abundance, which is 35. Everything over 100. So everything here will give us this. The next one is now this times this will give us 65x plus 31 times this. Let us use the calculator. So this one, 31 times 35 will give us 1085 divided by 100, and the answer is 30. Now we can remove the denominator here by multiplying 100 both sides. So we will have here 33,000 equal to 65x plus 1085, and this 100 and this one will cancel out. Now you like terms together, this one will come this way, and we are going to subtract 3000 minus 1085 equal to 65x. So this one will give us 1915 equal to 65x. So we want the value of x. We divide it by 65, divided by 65 both sides. So x equal to 29.46, and that is the mass of isotope X. Complete the following word equation and then write balance the chemical equation for the reactions listed below. So we have sodium hydroxide reacting with hydrochloric acid in form 1. You should know that this sodium hydroxide is a base, HCl is an acid. Therefore a base plus an acid will give you salt plus water. So here this one will give you sodium chloride plus water, right? So the chemical equation here is sodium is written as NaOH plus HCl, hydrochloric acid, will give you sodium chloride NaCl plus water. The status in form 2, you will learn them. So this one is a liquid, this one is aqueous, this one is aqueous, and this one is aqueous. Zinc oxide plus dilute. This is a base also. The oxides are bases, but solid in solid form. So zinc, this one will give you salt plus water. So let us write the chemical equation. Zinc oxide is ZnO solid plus dilute sulfuric acid. Sulfuric acid is written as this, aqueous. It will give you zinc sulfate. Zinc sulfate aqueous plus water. Zinc metal plus dilute nitric acid. This is a metal plus an acid. A metal plus an acid, you should know, it will give you salt plus hydrogen gas. So this one will give you zinc chloride nitrate plus hydrogen. Excuse. So zinc plus nitric acid HNO3, nitric acid aqueous solid, we give you zinc nitrate plus hydrogen gas. Because hydrogen here, there are 2 of them, you put 2 here to balance the equation. Calcium carbonate plus dilute sulfuric acid. This is a carbonate plus an acid. Carbonates plus acids will give you salt, water, and carbon 4 oxide gas. So calcium is written as this, calcium carbonate, a solid, plus sulfuric acid is H2SO4, which will give you calcium sulfate, which plus CO2, carbon 4, plus water. This one is a solid, this one is a gas, and this one is a liquid, aqueous, a solid. So this is, we call them status, and you will understand them as time goes by, so you don't have to worry. And if you don't know how to know which one, that is in form 2 work, salts. Calcium hydrogen plus carbon 4, I think it is something wrong there. Sodium plus water, metal plus water will give you metal hydroxide plus hydrogen gas. So this one will give us sodium hydroxide plus hydrogen. Sodium plus water will give you sodium hydroxide plus hydrogen. Hydrogen is a gas, aqueous. So that's how you write. Use information given below. Which solution we have M 2.5, N 5.5, all those. Which of the solution would you use to relieve stomach upset caused by indigestion? In the stomach we have hydrochloric acid, HCl. In the stomach. Therefore, if for us to relieve the stomach upset caused maybe by HCl, we need a base solution. So here, and we need a weak base and not a strong base. Bases have a pH that ranges from 8 to 14. Acids have a pH that ranges from 1 to 6 point something. So we can't use 14 because Z is a very strong base. We are going to use F, which is a weak base. So we are going to use F. The reason is that it is a weak base. It is a weak base. What will it do? A base plus an acid, it will do what we call neutralization reaction. A neutralization reaction is a reaction which gives you salt plus water and the stomach will stop aching. Which solution is likely to be diluted? Diluted hydrochloric acid is a strong acid, so it is 2.5. So maybe I have not mentioned. From 1 to 2 to 3, these are very strong acids. From 4 to 6, weak acids. From 8, 9, 10, 11, weak bases. 12, 13, 14, strong bases, very strong. Sodium hydroxide is an example of a strong base. So it is Z, which is equal to 14. Study the diagram below. Use it to answer the question below. So dry hydrogen is getting into this combustion chamber or combustion tube. In the combustion tube we have copper 2 oxide. Here you must know the colors of copper and the copper 2 oxide. Copper 2 oxide is black. Copper, only copper, is brown, already brown. You should know that. So what will happen? Why is it important to derive out all the air from the combustion tube before lighting the jet? It is for the security purpose, because the reaction between hydrogen and oxygen is explosive, so it is for to avoid explosion. When hydrogen reacts with air and it is burning, then it will explode. Therefore it is to avoid explosion. State and explain the observation made in the combustion tube. That's what I wanted us to do. So what will happen in the combustion tube? In the combustion tube we have copper 2 oxide, which is black, and it is heated. Hydrogen is a reducing agent. So what hydrogen will do, it will take away the oxygen from copper 2 oxide, and the copper will remain, because dry hydrogen is a reducing agent. So state the observation is that the black solid changes to brown. The black solid, the copper oxide, changes to brown. Brown is copper. So we will write the equation and you will see. The black solid changes to brown. Why? Hydrogen is a reducing agent. It reduces copper 2 oxide to copper, which is brown. Another observation is that a colorless solution is going to be formed, which is water. Write the equation here. We are going to write the chemical equation. So copper oxide, copper 2 oxide plus hydrogen, hydrogen will take the oxygen here, leaving copper, which is now brown, and this one is black, and now this one will combine with peroxidized to form water. So copper 2 oxide is reduced, has been reduced, and hydrogen has been oxidized. Oxidation is the addition of oxygen to a substance, and reduction is the removal of oxygen from a substance. So you can see the oxygen that was in copper has been removed. So from here up to here is reduction. State the substance which has been reduced. Which has been reduced? Copper 2 oxide. Copper 2 oxide has been reduced to where? To copper. Oxidized. Hydrogen has been oxidized. It is the one which has been added oxygen to form water. State the oxidizing agent. The oxidizing agent is the compound which provides oxygen. Therefore, copper 2 oxide is the oxidizing agent. Reducing agent, hydrogen. What is reduction? Removal of oxygen from a substance. Removal of oxygen from a substance is called reduction. These questions are yours. Please attempt those questions. They are for you. Thank you very much. Thank you for your time.